Hello everyone, my name is Mandeep Kumar. I am BTech third year student at Chandigarh Group of Colleges Landra from Electronics and Communication Department. I am thankful to the Emertxe Technologies for providing such a wonderful internship opportunity in IoT field. Uh, I am here to share my internship experience at Emertxe. Uh, I am here to share what I have learned during this internship period. So, moving further with our slides, this internship, I have learned about the various modules regarding C programming, then Internet of Things, embedded system, and I have made home automation stimulation project. So, moving further with our slides, first of all, we'll discuss about the C programming. C programming is a basic general purpose programming language, even though it is applied and used effectively in various specific domains because of its efficiencies and portability. It is created by the Dennis Ritchie at Bell's Laboratory in 1972. It is a free formatted language, means not a strongly typed language. C programming basically provide the library facilities which play an important role for the programmers. So moving further with the basic structure of the C program as follows. C program is categorized under as a header file, pre-processing directive, then the main function, then we'll write our code here, then terminate the program. This is our pre-processing directive with some header files like conio.h, studio.h, mat.h, and some scientific libraries and different libraries. So this is our main function. After this, our code will start from here. In this curly brackets, we'll write our code. With help of printf function, we'll display display what we want to represent in our console window. Here we'll write hello world. This hello world will print in the console window, and then provide a return function. Return 0. This 0 means will uh, will return the null value to the main, and after the return function our program will terminate. So this is the basic general structure of the C program. We'll move further. uh, in C programming, the basically topic covers are data types. Various data types are character, integer, float, double, then modifier and the qualifiers, then conditionals and loops, then operators, then arrays and pointers, then strings, functions, storage classes, and preprocessors. So data types are categorized as integral and then floating point. Integral basically categorized further as character data type, then integer data type, and floating values are categorized under as a float, then double. Float means the decimal values, and double is the precise value of the float. So then we'll look at the conditional construct. Conditional constructs are categorized under as single iterations, then multi iteration. Single iterations are further divided as if statements and its family, like if simple if, then else if, then if else if ladder, then nested if. Uh, it can also be categorized under the switch case. Uh, will provide different cases under the switch statement. Will then it is all conditional constructs can also be categorized under the multi iterations. These multi iterations can be provide as for loop, then while loop, then do while loops. These all are the loops which are used for the iterations. So moving further with the operators in the C language. There are many operators in the C language which are categorized according to their types as unary operators, then binary operators, and then ternary operators. These are further uh, divided into the operators types. These are used as increment decrement operators, then arithmetic operators, relational operators, logical operators, bitwise operators, spatial operators, assignment operators, ternary or conditional operators. These column represent the symbolic representation of these operators, like plus plus for the increment, minus minus for the decrement, and then double equal to for the uh, for comparison, then single equal to means assigning some value to the variables, then uh, this is means the not equals to, then these greater than or less than, greater than equal to, less than equal to are used for the comparison. And then these are the logical operators symbols like and, then or gate, then not gate. These are some bitwise operators, and or, then left shift, right shift. These are some special operators, and these are some assignment operators, and this is the ternary operator. So moving further, then I have learned about the Internet of Things in this internship module. Internet of Things is the network of the physical object that contain the embedded technology to communicate and interact with their internal or the external environment. So, in other words, IoT can be described as an extension of the internet and the other network connection to the different sensor and the devices. These devices may be some simple object or some the home appliances like the light bulbs, locks, vents, etc. Or these may be the some high degree of the competitive or the analytic capability devices. So we'll discuss the applications of the IoT in the various domains. This IoT can be used for the gaming purposes, for the home automations, for use for the security purposes, for used in the different domains in the appliances, and used in the industries, then used for the home automation as to controlling the light bulbs or the different appliances like ACs, microwave ovens, then TV, television. And then IoT can be used to monitor and the surveillance purpose also, uh, and controlling the different devices by providing the integrated environment. So IoT vastly used for many purposes to interacting, to making the devices interacting according to their environment. So moving further, these are the some applications of the IoT. IoT is used for the thermostats and the security system as I have discussed earlier. These are used for the variable of the health and the fitness tracking, then for use for the diagnostics of the autonomous vehicles, then for used in the smart factories. IoT can also be used to control and monitor the traffic light system in smart cities. IoT can also be used in the agriculture sector for crop monitoring and crop harvesting. Then IoT can also be used in the retail supply chain tracking. IoT can also be used to monitor and diagnosis of the various diseases. IoT can also be used in the health sector to monitor the and provide the better health facilities. So moving further, uh, these pictorial diagram represent the various application of the IoT in the various domains. like for consumer and the home sector, then for building the better infrastructure. Then IoT can also be used for the security and the surveillance purpose, used in the transportation to make the transportation better. Then IoT can be used in the industrial sector. Then in the retail sector, have I have discussed earlier regarding that. All these applications are used in the various domains as discussed here, in health sector, and various and many more applications of IoTs are there in this era. So moving further, then I had learned about the embedded system. Embedded system are the basically the combination of the hardware and software which are intended to do some specific tasks. So embedded system can have the basic three components. These are the hardwares, then application software, then the real-time operating system. Real-time operating system make the interaction between the hardware and the software and provide the graphical user interface environment. And RTOS means real-time operating system is a set of the rules during the execution of the application program. So moving further, uh, moving further with the embedded system components. Embedded system component has the main component as a microcontroller, means the CPU, which controls the other units. Then it has some software embedded in it, software, then some hardwares like sensors and actuators, analog to digital converter and digital to analog converters for processing data, and has some real-time operating system, provide user interface. These units are interconnected to each other to perform some specific uh, task. Uh, these are these all are integrated and dependent on each other to perform some specific tasks and intake or outtake the instructions. So moving further, these are some example of the embedded system can be used to design the digital systems, like digital systems for the communications or the for making the digital devices like the microwave on ovens, then digital washing machines, then TV, smart TVs. Then embedded system is utilizes its application in the cameras, then smart electrical smart and the electrical vehicles, then in smart almiras, then in mechatronics. Embedded system also utilizes its application in the various domains like the aerospace domain for making the uh, devices to perform some specific tasks like autopilot mode in the aeroplane and the missile system. Then for providing the user applications like mobiles and providing the rovers. These all are the typical example of the embedded system which have some program in form of some softwares and have some hardware which are interacting with each other to perform some specific task. So moving further, uh, then we'll discuss about the Arduino Uno. Arduino Uno is a microcontroller board which is based upon the Atmega 328. It has 14 digital input output pin, out of which 6 can be used as PWM outputs and 6 are as analog input. Then it has a 16 megahertz ceramic resonator, USB connectors, and power jack and ICSP headers and a reset button. So we'll discuss the structure of the Arduino board as follows. This is the reset button, and this is the type B USB connector, which is used to reload or programming the Arduino board. This is the Atmega 16U2 chip, which provide the inbuilt driver to uh, convert the USB to the serial convert the USB to the serial data. And then this is the DC jack, which is used to supply the power to the Arduino board. Then this is the Atmega 328P microcontroller, in which the program is burnt. These are the digital input output pin, out of which these are the I2C pin. Uh, these are the serial clock and the serial data address. Then Arduino board has the two ICSP connector. This is one and this is second ICSP connector. ICSP connector means in circuit serial programming connector. These are used for the serial programming. Then Arduino has the six analog pin. These are from 0 to 5. And then these are some different pins like reset for 3.3 volt, 5 volt, then ground pin. Arduino is basically work on the operating voltage of 5 volt. If the voltage is greater than 5 volt, our Arduino board will burn out. So so we'll always so we always provide the voltage 5 volt, approximate 5 volt to the Arduino board. So these I2C pins are used to interface the CLCD displays. So CLCD display and may be used for the multi-functioning. So these are the LEDs, and these are the serial data transmission pin or receiver pins. TX stand for transmission, RX for the receiver. These are the serial transmission pins, receiver and transmission pins. These are. So moving further, now we'll discuss about the project that I have made during this internship program. The project so the project is based upon the IoT, which is for the home automation solution. We'll discuss about the objective of the project. The main objective of this project is to build a smart home device which can be used to control and monitor the home appliances via internet. Uh, the home automation devices that build can be integrated with almost home appliances and can be controlled and monitored remotely from the various part of the world. So the main scope of this project is that it provides the integration between the home appliances and the uh, with the real-time user interface, and has real-time application which can be controlled or monitored remotely uh, uh, through the use of internet. So the home automation should be stimulated on the Pixim Lab Stimulator Blink IoT app application used to control the devices, and it should be able to control the light and the temperature of home, inflow outflow of the water in the water tank. These are the requirement for the home automation solution for virtual setup. Will uh, will use the virtual window to perform these uh, to perform to build this project. We use the Pixim Lab Stimulator. We use the Pixim Lab Stimulator, which provide the virtual Arduino board. With the help of this Arduino board, will interact with the different different devices, and through the Blink mobile app, which provide the cloud facilities. And with help of this Blink cloud, will monitor and control the home appliances remotely. These diagrammatic this diagrammatic representation shows the interfacing of the home appliances with the Arduino board. Then Arduino board interact with the Blink cloud server, and we can control Arduino board through the Blink cloud application. So moving further, the main requirement to build these projects are we should have LED temperature system like temperature sensor, like analog to digital converter, then LDR, then serial tank for serial communication, then Ethernet shield, and Blink IoT app. So moving further, Blink IoT app provide the cloud facilities. Then this is our Arduino board, and this is our temperature system, and this is our CLCD display. When the temperature rises or temperature downs, this information goes to the Arduino board, and Arduino board send notification to the cloud app, and cloud app further send the notification to the Arduino for controlling purposes. Then these uh, notification or the control goes to the temperature system, and the notification goes to the CLCD display, which show the actual temperature of the system. So moving further, this can also be used to control the water tank, uh, for water level in the water tank. So uh, whenever the water tank whenever the water tank is empty or water tank is full, the notification goes to the Arduino board, and this notification further goes to the Blink cloud application. This application provide the control to the Arduino boards. Then Arduino provides some notification to the CLCD displays and the water level to control the water level. So the information of the water level is displayed to the CLCD display for uh, real-time application. Real-time application. This can be used for the real-time application. So we'll move further. This is the virtual setup of the project and the different devices and the sensors which can be integrated to interface with each other to provide some real-time application. This is our Arduino board. This is our Arduino board. This project is totally based upon the is built on the stimulator. So stimulator used here is PiximLab. PiximLab provide the virtual Arduino board. Then provide the serial remote tank. This blue portion represent here is the water level, and the uh, water level is represented in liters here. 2670 liter water is in the tank, and the whole capacity of tank is 3000 liter. And this is the LEDs used for the gardening light. These are for the gardening light. And this is the LDR sensor. This is the temperature sensors, can be used for the heater, cooler, and then can be used for the tachometers. This is the A to D converter, means analog to digital converter. Then this is our Ethernet shield. This is our Ethernet shield. Then this is our CLCD display. This is our CLCD display. So we'll see how the program is burnt. Program is burnt through the hex file. We load the hex file to the Arduino board. Then then stimulate our uh, appliances, home appliances like water tank, then gardening light, then temperature of house, etc. We'll see the code structure of we'll see the code structure. So this is the code which is used to burn in the Arduino chip. This is the code which is built to some real-time application using Arduino board. Uh, this is the code. This is the this code for LDR for controlling the gardening light. Then these are the macros for the LDR. Then this is the code for the serial tank to control the inlet and outlet flow of the tank. Then these are the macros for the and these are the macros for the serial tank. Then this is the code for the temperature system for controlling the temperature, and these are the macros for the temperature system. And this is our main code. This is main code, and these are the macros for the main file. So this code is used to perform some real-time application which is or burnt or load to the Arduino board. So coming back to our slides. So now we'll see the real-time application. Now we'll see the virtual demonstration of this project. So first of all, we load our hex file. So I have already loaded recently, so I reload last. So I reload last, and this shows the temperature, T for temperature, V for volume. Here, here the volume of water level in the tank is 24 2490 liters, which is represented here 2490 liters. And this is our water tank, and this shows the temperature of the system, which is 27.34 degree Celsius. So now we'll open the Blink Cloud app. Now we'll open the Blink Cloud app. Now we'll click on the home automation template. Now coming back to our uh, virtual stimulation. So uh, whenever water level is less than 20 whenever the water level is less than 2000, it send notification to our mobile app that the water level is less than 2000. So it automatically turn on the inlet valve, and when that our tank is full, it automatically turn off the inlet valve. So we'll see, as if we turn on the heater, whenever the temperature rises 35 degrees Celsius, it automatically turn off the heater button, and temperatures cools down to the 27.34 degree Celsius. So now here these are the gauge for the water level, water volume, and this for the temperature. These are the uh, switches for the cooler, inlet valve, heater button, then the outlet valve. The water level is shown here 2490 liters, and this shows the temperatures. So turn on the inlet valve, whenever I turn on inlet valve, so tank is completely filled and it show notification that our water level is full, and it automatically turn off the inlet valve. So now if I turn on the outlet valve, whenever the level is below than 2000, it automatically turn on the inlet valve. So it automatically turn on the inlet valve. Now if I close the outlet valve, if I switch off the outlet valve, when our tank reaches to its full capacity, it sends a notification that our water level is full and automatically turn off the inlet valve. So this is application for the water tank. Now we'll see the heater. This is our gardening light. This is our gardening light with help of LDR sensor. With the help of LDR sensor, our gardening light is automatically turned off, turned on. LDR sensor basically depend upon the resistance. Whenever there is a light, whenever there is a light, it automatically turn off the LED. When there is a dark, it automatically turn on the LEDs or the light bulbs. Now if I on the heater, the temperature rises to the 35 or above than 35 degree. If the temperature rises to the 35 degree, it automatically turn off the heater. And now if I on the cooler, the temperatures goes down to the 27 degrees Celsius, and it send notification that temperature is above. If there is temperature above than 35 degrees Celsius, it send notification that our temperature is above 35 degrees Celsius. It automatically turn off the heater. These are the notification which are coming from the Blink cloud. So this is our whole project, which can be implemented for the real-time application for making our home smart. Uh, so moving to our PPT slides. Moving to our PPT slides. So at last we conclude that Blink cloud application and the Pixim stimulator can be used for building the real-time application. From these Blink cloud application will control the LED temperature system, then cereal tank, then heater and the cooler, and the water level can be controlled using Blink application. So CLCD display act like a dashboard which displays the events and the widget of the cloud app, which displays the events like our temperature and the volume of the water level. The other widgets on the Blink Cloud app button like cooler as shown here, cooler inlet valve, heater button, outlet valve, water volume and temperatures, which shows the controllability and observability for the user, that how our temperature of the system rises, how much the temperatures goes down, how much the temperature rises. All these informations are coming to our mobile mobile application using the Blink Cloud app, Blink IoT app. So these are the gauges which are used for the water volume and the temperature system. So so this is the whole about our project. So thanking you